GCSE Physics Boosters Resistance 1. There's quite a big topic, resistance, so I've done it over 2 videos and this is the first of them. Voltage, current, resistance. They're the 3 big ones, and this video is about resistance. Before we talk electricity, imagine this. We've got 2 big containers full of water and we punch a hole in one and a large hole in one and a small hole in the other. Now what's going to happen is that they're going to leak, water's going to come out. Now the rate of flow of water, how much water comes out every second, will be bigger in the first container. Why? Well, because the hole is bigger, it's easier for the water to come out. If you like, that hole has a smaller resistance, so the current, the rate of flow of water, will be bigger. The smaller hole has a larger resistance. It's harder for the water to come out, so the current will be smaller. So you get the idea, the relationship between resistance and current. If the resistance is big, the current is small. If the resistance is small, the current is big. Okay, it's harder for water to flow through the smaller hole. This hole has a larger resistance to the flow of water. I've already said that. Get on with it. Okay, now look at these 2 circuits here, and you've got a 9-volt power supply, but the first circuit you've got a 10 ohm resistor, and in the second one you've got a 20 ohm resistance. And look at the currents. In the first one the current is 0.9 amps. In the second one the current is half as much, it's 0.45 amps. So when we double the resistance from 10 to 20, then the current is half as much. The current in the second circuit is half as much as in the first. This is because the resistance of this circuit is twice as much. Small resistance, big current. Big resistance, small current. Okay, now what else does the current through a component depend on? Well, it depends on the resistance of the component. Now it's also going to depend on the voltage that we put across it, the potential difference across the component. This is a very important circuit. You should be able to sketch this by yourself. Voltmeters in parallel, ammeters in series. And what we're doing is we're increasing the voltage. I'm using a variable power supply. There is another way of doing it using a variable resistor, but here I'm just using a variable power supply, which is probably what you'll do. And I'm increasing the voltage from 0 to 9. That's my independent variable. And my dependent variable is the current. Okay, voltmeter in parallel, ammeter in series. We get our results, we plot a graph, and you can see here now for a fixed resistance or a resistor, okay, the graph is a straight line. So the graph of current against voltage is a straight line. We say that it obeys Ohm's law. Ohm's law says that the current through the component is directly proportional to the voltage across it. In other words, the graph is a straight line. We should add to that at constant temperature, because temperature makes a difference as well. But here, this fixed resistor, its resistance doesn't change, okay? And it obeys Ohm's law. The graph is a straight line. How do we calculate resistance? R equals V over I. Okay, if you know the voltage across the component and you know the current going through it, then R equals V over I, and resistance is measured in ohms. And the symbol for ohms, we use this Greek letter omega for ohms. And by the way, this equation, or one form of it, V equals IR, you need to recall that. You need to remember this equation. So V equals IR, so R equals V over I, or I equals V over R, if you need it. Here's some practice using this equation. I suggest you get your pen and paper and calculator and pause the video and do these, and I will show you my answers in 3, 2, 1. Okay, so what is the resistance of the resistor that produced the graph on the last slide? You can take any point on the graph because it doesn't matter, because its resistance doesn't change. R equals V over I. I said 4 divided by 8, so 4 volts, 8 amps gives you 0.5 ohms. What current will flow through a 20 ohm resistor if we put 10 volts across it? So I equals V over R, 10 over 20, 0.5 amps. And then what current will flow through a 10 ohm resistor if we put 10 volts across it? And if you look at the sum there, it's twice as much. Because the resistance is half as much, the current will be twice as much. What voltage would be needed to make 0.8 amps flow through a 47 ohm resistor? So V equals IR is 37.6 volts. And a current of 8.4 amps flows through a kettle connected to a 240 volt supply. Calculate its resistance. R equals V over I is blah blah is 28.9 ohms. I've said it many times, I'll say it again. Write down the equation, rearrange it if you need to, bung in the numbers after you've rearranged it, work it out, don't forget the units. Now, this component does not obey Ohm's law, and it's a lamp, or a filament lamp, or just a bulb. Yeah, likely the 6-volt bulbs you'll be using in physics lessons. The graph isn't a straight line. It does not obey Ohm's law. Its resistance changes. Okay, it does not obey Ohm's law. Possibly you could argue that it's a metal, and because the bulb gets hotter, you know, it doesn't have to obey Ohm's law because it's getting hotter. Temperature's a factor. But you remember, it does not obey Ohm's law. Use data from the graph to calculate its resistance when it's got 2 volts across it and when it's got 8 volts across it. So at 2 volts, look at the current, and at 8 volts, look at the current, and then it's just V over I. Yeah. If you're asked to do this on an exam, draw these lines, by the way. So from 2 volts up, and then draw across, see what the current is. From 8 volts up, across, see what the current is. R equals V over I, so for 2 volts, 2 divided by 4 amps is 0.5 ohms. And at 8 volts, 8 divided by 9.3, I reckon that is 0.86 ohms. Here's another component which does not obey Ohm's law, and it's called a diode. Now, you can have a diode on its own, you can have a light emitting diode. There's loads of LEDs in your house. There's a ridiculous number of LEDs, particularly if you've got an LED television. And a diode is like a valve. A valve only lets water flow one way, and a diode will only let current go one way, in the direction of the arrow. Okay, so in that direction, in the direction of the arrow, it has a small resistance, and in the other direction it has a large resistance, so no current flows. Notice that you need a little bit of voltage to get it flowing, about 0.7 volts. Okay, and whenever you use a diode, you usually have a resistor in series with it to protect it, because if the current's too big, then it will ruin the diode. But anyway, you need to know this graph, and this is a diode or an LED. Here are some questions for you to have a go at. Again, I suggest you pause the video. I'll show you the answers in 3, 2, 1. So suggest what each component is. The first one is a fixed resistor. The second one is a bulb. And the third one is a diode. Notice that on all of the graphs, we're showing positive and negative voltages. For the resistor and the bulb, it doesn't matter. Yeah, we say they're passive components. It doesn't matter which way round the voltage is, but for the diode, it does. so we show positive and negative voltages. What is Ohm's law? Well, current is proportional to voltage. We should put in brackets at constant temperature. And which of those components obeys Ohm's law? Well, the fixed resistor, because it's a straight line. Lastly, if the battery for a device is connected the wrong way round, then the device may be damaged. How might we protect the device? What we could do is put a diode in series with the power supply that only lets the current flow the correct way. So if some plonker puts the battery in the wrong way round, it doesn't matter because the diode will stop the current from destroying the device.